All right, welcome back everyone. So today I'm going to be going over the MCIT curriculum. Now again, the MCIT curriculum is consisting of 10 courses, 6 of which are core courses, and then 4 are left to electives. Now today I'm going to be going over basically just generally what the 6 courses are and what I'm interested in taking in for electives, but also just some future plans and predictions of how I might set it up and what I plan to take in the following semester. Now again, all these course descriptions are available in the link below online on their website, and you can check more out over there. Now the first one, which is Introduction to Software Development. Let's see, this course is an introduction to fundamental concepts of programming and computer science for students who have little or no experience in these areas. Includes an introduction to programming using Python, where students are introduced to core programming concepts like data structures, conditionals, loops, variables, and functions. Also provides an introduction to basic data science techniques using Python. The second half of this course is an introduction to object-oriented programming using Java, where students are introduced to polymorphism, inheritance, abstract classes, interfaces, and advanced data structures. Students will also learn how to read and write to files, connect to databases, and use regular expressions to parse text. This course includes substantial programming assignments in both Python and Java, and teaches techniques for test-driven development and debugging code. Alright, so it looks like this course is mainly in Python and Java, and it's kind of split in half. Now, I have some previous experience with Python, and a lot of those descriptions about loops and variables made sense to me. But I'm actually surprised to see that there's a little section here that it said using data science techniques with Python. Now, that's really exciting because I'm really looking forward to learning more about data science and hopefully pursue a career as a data scientist. Now, a lot of what I'm not familiar with is Java, which I hopefully learn to learn, and also a lot of stuff like it said here, parsing text, connect to databases. Not familiar with that at all, so that seems really exciting to check out. All right, so now the next course, Mathematical Foundations of Computer Science. This course introduces students to math concepts that form the backbone of the majority of computer science. Topics covered include sets, functions, permutations, and combinations, discrete probability, expectation, mathematical induction, and graph theory. The goal of the course is to ensure that students are comfortable enough with the math required for most of the CIS electives. Alright, so this is essentially a math course, and it's focusing on discrete math, which, like it says, is the foundation of a lot of computer science research and, of course, classes. Now, I have a little bit of discrete math background. I've taken logic for my philosophy degree, and I learned a little bit about discrete math. But I think I'll be taking this course even though I may possibly wave out of it, to know more about probability and graph theory, stuff I've never really studied, but it's obviously in a lot of computer science and even data science today. So to get a really big grasp of the concepts, it's very important to know all the math. So I look forward to taking this course. All right, next. Introduction to Computer Systems. This course does not have prerequisites, but CIT 591 is a co-requisite. Okay, so it looks like it'd be helpful to know at least prior or simultaneously some knowledge of that first class we were talking about. This course provides an introduction to fundamental concepts of computer systems and computer architecture. Students learn the C programming language and an instruction set, machine language, as a basis for understanding how computers represent data, process information, and execute programs. Okay, so this looks like a more quote-unquote low-level class in the sense that you're really taking a dive into the depth and bottom base level of a computer. I was talking about C, which is kind of a low-level language, which is trying to talk to machine-level language. And I've heard C is very hard, but I definitely want to learn more about that to see what exactly all the fuss is about. But nothing more to say about that. All right, next, data structures and software design. I hear these words a lot, data structures, software, design, stuff like that. It's interesting to see what this is up to. It says that you should at least have the first class knowledge of that Java class. All right, so this course focuses on data structures, software design, and advanced Java. The course starts off with an introduction to data structures and basics of the analysis of algorithms. Important data structures covered include arrays, lists, stacks, queues, trees, hash maps, and graphs. The course also focuses on software design and advanced Java topics such as software architectures, design patterns, and concurrency. All right, I'm barely familiar with any of those terms, but I definitely hear them thrown around a lot with discussions in software, computer science, stuff like that. It's one of the reasons why I applied and joined this program is so I can understand these fundamentals and talk to other engineers, other technical, maybe managers, stuff like that. But it looks pretty exciting. I actually can't wait to finally take this course and then by the end of it, actually know what all this means and then use it on some projects and further courses that I'll be taking. All right, next. Computer Systems Programming. This course is a continuation of 593 and introduces students to fundamental concepts in computing systems. This course is divided into two parts. The first half of the course introduces important concepts in modern operating systems, processes, scheduling, caching, and virtual memory. The second half of the course provides an introduction to fundamental concepts in the design and implementation of networked systems, their protocols, and applications. The course will use the C program language and will develop your knowledge on C system calls and libraries for process thread creation and manipulation, synchronization, and network communication. All right, so again, another class that I'd love to hear more about. I hear a lot about networks, systems, and a lot of stuff with memory and cache in discussions about computer science. Actually, I hear this a lot in discussions of security, specifically cybersecurity, fraud, networks, stuff like that. So love to hear what exactly is a system in the computer science sense and how do modern developers use that and provide more research on that and innovation. All right, finally, the last core class is Algorithms and Computation. Now, these are words I hear a lot, and it looks like it's a more theoretical class. This course focuses primarily on the design and analysis of algorithms. It begins with studying and searching algorithms and then investigates graph algorithms. In order to study graph algorithms, general algorithm design patterns like dynamic programming and greedy algorithms are introduced. A section of this course is also devoted to understanding NP completeness. All right, so it looks like you need that math class and then obviously previous programming courses. Now, here, I definitely want to know a lot more about algorithms, not in the sense of just, I guess, taking this class, but also even research on algorithms. I've heard a lot with talking with other computer scientists and other researchers, especially in machine learning, about particular algorithms, both in the machine learning sense and even in theoretical computer science. Here is talking about NP completeness. I know that's a term in theoretical computer science, but I'd love to actually know more and actually get a concrete introduction into learning about that. All right, so let's move on to electives. MCIT Online students must complete 4 graduate level electives. MCIT Online is still in the process of developing new electives. Additional elective courses planned for the development include artificial intelligence, blockchain, and more. All right, that seems exciting. Now here I'm gonna just focus on just 2 particular electives that seem interesting to me and I definitely want to take, but it sounds like there's much more in development and I definitely want to be paying attention to that. I definitely want to look at that AI and blockchain class. That definitely looks very interesting. All right, so let's look at this next class. Fundamentals of Linear Algebra and Optimization, Math for Machine Learning. So it looks like it's another math class. There are hardly any machine learning problems whose solutions do not make use of linear algebra. This course presents tools from linear algebra and basic optimization that are used to solve various machine learning and computer science problems. It places emphasis on linear regression, data compression, support vector machines, and more, which will provide a basis for further study in machine learning, computer vision, and data science. both theoretical and algorithmic aspects will be discussed, and students will apply theory to real-world situations through MATLAB projects. All right, that sounded very exciting. I definitely hear those terms thrown out a lot. I've never personally taken a linear algebra class, so it'd be pretty exciting to actually get into that. I've always wanted to delve more into math, but never really put the time and effort into it. And it obviously says that we're gonna be learning what these foundations of data science techniques are really about. And it says the class is in MATLAB. I've actually taken a previous MATLAB course, so it'd be nice to hear a little refresher about that and even just get more practice and experience with that. All right, so this one says statistics for data science, and it looks like it requires that previous core math background, CIT 592. In this course, students will learn a broad range of statistical and computational tools to analyze large datasets. This course provides a solid foundation of data science, statistics, and machine learning to make data-driven predictions via statistical modeling and inference. Using case studies and hands-on exercises, the students will have the opportunity to practice and increase their data analysis skills using Python. The objective of these case studies is to identify and implement appropriate modeling and analysis techniques in order to extract meaningful information from large datasets. Awesome. So one thing I've kind of heard and realized is that data science requires a pretty robust and rigorous knowledge of statistics, especially in the sense of data. How are you extracting it, collecting it, and then maybe visualizing and representing it? It's very important to know what is an appropriate statistical method. Now, a lot of the times I've tried to learn it on my own, but it seems like this class seems like a great idea to just get introduced to the math portion so that you actually understand what technologies you're implementing. And specifically when you're writing code in Python, as this class seems to be in, it's important to know why you're selecting that model, why are you coding it that way, and what are you ultimately trying to do. It's always important to know the theory behind why you're actually implementing, why you're executing, and ultimately planning a certain design for a model and analysis. All right, so that seems to be the bulk of the program, which is those core courses and a couple of electives that I was interested in, and their course descriptions. Now, is there any specific course you guys are interested in or any aspect that you want to kind of explore? Let me know down below, but thanks for watching.